Okay, so for 31, the average mass of an adult human is about 60 kilograms, while the average mass of an ant is 4 times 10 to the negative 6 kilograms. In 2010, the total population of the world was 7 billion. All right, and so let's put these in scientific notation. So 60 is just, 60 is just 6 times 10 to the first, 6 times 10. And we're multiplying that by the human population, which 7 billion is 7 times 10 to the 9th power. Now, when I multiply that, I get, once again, remember we multiply our numbers outside. And so that's 42 times 10 to the 10th power. And we'll leave that right there. Now, for the ants, I'll do that in purple. Here we're told the mass of an ant is 4 times 10 to the minus 6. Now 10,000 trillion, so let's 10,000 times 10 to the 12th. Well, this is 10 to the 12th. Now we're counting 13, 14, 15, 16. So this is the equivalent of 10 to the 16th power. All right, so I'm going to erase all of this. And so we basically get, that's 1 times 10 to the 16th. And so when we do this, we get 4 times 1. Here, I'll do that in red. 4 times 1. And that becomes 4 times, now minus 6 plus 16 is just 10 to the 10th power. And look here, 42 times 10 to the 10th, 4 times 10 to the 10th. Which is bigger? Clearly humans. In which case, I would just do 42 times 10 to the 10th minus 4 times 10 to the 10th. And when I do that, my answer is going to be in 10 to the 10th, but it's going to be 38 times 10 to the 10th. So 38 times 10 to the 10th. But that is not scientific notation, right? I need to move 1 to the left, which means I'm adding 1 here. Right? And once again, the explanation for that is when I move the decimal to the left, it's like I'm dividing by 10. So I need to multiply by 10 here. So it's basically like 10 to the 10th times 10 to the first. I add them together. That becomes plus 1. Right? Erase all this. Erase this. And I end up with getting 3.8 times 10 to the 11th kilograms. That's how much more mass of humans on Earth than ants. And so we would write a sentence. It's like humans have a total mass of 3.8 times 10 to the 11th kilograms more than ants. And that's it. All right. For problem 2. A helium atom has a diameter of about 70 picometers, 70 or 1 trillion. So this is going to be 70 times 10 to the minus 12. 1 trillion goes into a meter, right? Now, if I want to put that in scientific notation, once again, I'm dividing by 10, moving 1 decimal to the left, which means I need to multiply by 10 here, and that becomes 7.0 times 10 to the minus 11. The diameter of the sun is, we have to count, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the diameter of the sun is 1.4 times 10 to the 9th meters. So how many times larger? Well, we would do 1.4 times 10 to the 9th over 7 times 10 to the minus 11. Now, 1.4 divided by 7, that's just going to be 0.2. And you could do 7 into 1.4 like this. So that goes in 0, 14 goes in 2, and that's where the decimal is, 0.2. So 0.2. Now remember, times 10 to the 9 minus negative 11. So that's the same as saying plus 11. And so we get 0.2 times 10 to the 20th. But it's not in scientific notation. I need to move 1 to the right, which is like, once again, multiplying by 10, I subtract 1, and so we get 2 times 10 to the 19th. And so what you could say is the sun's diameter, and it's the end of a day, diameter is 2 times 10 to the 19th times bigger than a helium atom's diameter. And that's it.